Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about kickstarting your organizational transformation to become data-centric with our special guest, Sarah Kalicin, lead data scientist for data centers at Intel. Sarah, welcome to our podcast today.
Thanks for having me, Darren. I'm really excited about talking about this.
You know, we've spent some time talking about data scientists. In fact, we really should start a whole series on, I come from the IT world, you come from the data scientist world. And it was funny when we first started talking about these things, you had a different paradigm than I did, and we weren't meshing until all of a sudden we go, oh, you mean this? And we drew a little box and I put data science in there, and you go, yeah, that little box is all this stuff. And I went, oh my goodness, I can't believe, I didn't know any of this stuff. So it's been great working with you and talking about this. And today, this is going to be great because you've come up with this great idea on how can we operationalize data-centric, data analytics, data, AI, machine, all that stuff. How can we operationalize this stuff? So welcome. I'm very excited about today.
I'm really excited too. Thank you for the introduction.
So let's dive right in. So tell me, how do I operationalize analytics?
So for one thing, I want to step back a little bit on here because we hear about machine learning and we're like, oh, machines are going to learn. But in reality, it's not as simple as that. I like using this example. A lot of people think, hey, data is the new electricity. And, if you think about electrical system, what it's entailed, you have something like a power source, and then you have some wires that go to some kind of light bulb and so forth. And you pretty much know that as long as you have a power source and the wires have high integrity, like there's nothing, making it short circuit, that you can turn off the light and then 6 months later be able to come back and say, and flip that switch and know that, the light bulb will go on. You don't have that with an analytics system at all. In fact, you have so many different types of what I call short circuits that can occur all through that system itself. So to be able to go turn on that light bulb, getting that insight, you have to do some really well choreographed, making sure everything's in check and the data is able to go through that system very cleanly. So you have so many more things of what I call short circuit failures that can occur. So this is one of the reasons why it is so important to have the right people on the teams and in the organization working through and understanding all the different types of faults that can actually occur, or you're not going to get the right insights on there.
So to reiterate what you said, because I've done this myself, I set something up once in a spreadsheet, and it created some really beautiful, pie charts or bar charts. It gave me some insight that one time, and then I come back 6 months later and it doesn't work. And that's because you have too much variability in the system, is what you're saying, right?
You have a lot of variability. You also have to realize that, spreadsheets and so forth are great. They can be human readable, but they might not necessarily be computer readable. Meaning that, you can read the numbers and so forth, or see, catches on data. But as the computer goes through, you need to make sure that the data is clean, because garbage in, garbage out. You need to make sure the data is formatted. Anytime you go and use a machine learning algorithm, the data has to be formatted in a certain way. You have to tell what data is what data, and that it's a certain is in a certain format is characterized in a certain way so that the algorithm understands what it's bringing in and being able to look at the patterns appropriately.
So it's much more complex than the simple light switch, was what you're trying to say
right,
here.
Right, it is. So this is where, your data engineers, your data scientists, and your other supporting data architects are really important. And the other part too is, making sure that you have the right business questions. The business question and having the foundation, organization foundation that helps the organization to figure out what are we trying to answer from our data. What do we need our business to be able to get some insights from, or how do we paint a better picture of what our landscape actually looks like, and what data will allow us to do that.
So you've kind of come up with a, I wouldn't say a formula, but it is kind of a formula or a roadmap. How do I then approach this? Because for a lot of CIOs or CDOs, they don't know where to even get started, right?
Right. We work with a lot of the Intel field people, and I've been brought into projects and meetings with customers, and some of the most common things that I hear are, our CIO or our CEO or our CXO wants us to be doing analytics, AI, big data, all the buzzwords and so forth. And it gets a lot of the organization going, yes, we can do this. Really what executives really need to do is take the ownership of, this is how it's going to help our business. Here's our business strategy. We want to have a better picture of what's happening with using data, so that we can make sure that we're getting a bigger picture, a more complete picture of what's happening in that landscape. So the more that you can find data sources that can paint that picture, the better off the organization is. They can be able to pivot. And and even if you don't have data, just knowing you don't have that data is enough to be able to say, okay, are there proxies and so forth. So the first part of it is, we have to have analytics or AI. It's a great thing just to get people to say, we're going to make the change. But then you have to go and see what the business value is and start creating a strategy around that. What does success look like? What kind of landscape do we want to be able to picture so that we know how to work?
So it's primarily, if you're focusing on the organizational foundation on data first, we gotta do that first.
Right. And
Okay.
once you outline that, what needs to be accomplished, then you have to start breaking it down into smaller parts, and then start saying, okay, what data do we need to have that will help paint this? And finding those data sources. Some of those data sources are going to be in, data over here, over there, here, but you might also find out, I don't have any of that information. And then you have to go and figure out how to go collect that information, and if it's reliable. So the next part is the data collection and preparation. We need data, our data's a mess, and then spending a lot of time trying to get this together, trying to make a story out of that. And this also entails of not just, having data scientists. The data scientists are there to help make sure that you're going to be able to take that data and make stories of it. But you really need to get your domain experts, your business people, your marketing people, whoever else, whatever that business value comes from, those domain experts have to be involved because the more that you can get these teams together, they know how to work together, they feel empowered to work together, the more successful this entire journey is going to be.
So from what you just said, that's interesting because we talked about this before. I can't just say, you guys over there, you guys go do data analytics. You can't do that, right? You're saying not one person can know all the domain expertise in your company, but you have people understand how to work with data. They need to work with other people. So it's not a throw it over the wall, go tell me the best way to do data analytics, right?
Right, precisely. I mean, the thing is, if you throw it in, the data into a back room with your data scientists, you don't know what you're going to get. You got a couple of things going on. One, they're going to come out like 3 months later and say, "Hey, I got this greatest algorithm or this greatest model," and then your domain experts who are trying to use it are like, "This is garbage. This doesn't make sense to me." Either they're not going to be able to trust the information because they don't understand what has happened to the data, or the data scientists have essentially, identified patterns in there that aren't realistic. And that's where the domain experts are going to go, this isn't real. So you don't want to set your data scientists up so that their work ends up becoming an academic exercise, which means it doesn't get absorbed into the organization. It doesn't add value to the organization.
Well,
So
and that leads to your next thing in your pipeline, which is that insight creation, right? I can gather all and prep all this data, but if it doesn't provide me anything valuable, I mean, it doesn't do me any good, right?
Right. So the next part of it is, having the data scientists work with the domain experts to try to figure out, is this data valuable? Do we get anything out of it? How does this information come together, and how can we make models? Because another observation that a lot of organizations will find out is you have data convenience. You collect data because it's convenient, but it might not necessarily be the right data. There might be a lot of things wrong with it because you've never used it before, and it might provide insights that answer totally different questions. So those are some of the things that, as you're going through this journey of collecting data and trying to figure something out, you'll find out that, oh, this data is not as reliable, or there's other issues that you have to go back, and that becomes another type of fault or a short circuit in the process.
Okay, so let's talk about the last thing, right? I've got insight. I've got all my data. I'm getting insight. Now, what should I do with it now?
So the next part of it is trying to get the data so that you can actually operationalize it. And that is, you're then going to be there's a workflow of creating the insights. And then once you get the models and other you were able to get those insights, and people trust it and like, hey, we want to be able to use it, then you also need to create another data pipeline that basically allows that data to flow, so that as data is being updated, you can repaint what that picture looks like.
So I've seen this before. I've seen organizations go and do a science experiment.
Right.
They do it one time, but they don't set it up so it can be used on a daily basis or operationalize it, right? So that's what you're talking about here, is how do I operationalize my pipeline, right? So that I can use this data in a valuable way all the time, instead of I'll go chase a rock somewhere, right? Which we've all done before.
Right. So, this is going back to your domain experts or those people who are consuming it and trying to figure out, how do they want to be using that? Do they trust the data? Do they, is it getting to the right place? Is it painting enough of a picture that people feel comfortable with it, that it's giving them the insights that that they feel like they're empowered to, hey, this is empowering me to make better decisions for the business. Do we pivot this way, or do we pivot that way?
You've done this in other organizations before, right?
Yes.
So let's have an example. Let's go through this as if we're walking through this thing. So
Okay, so one of the things that we're going to be talking about is like, let's just take a manufacturing example. I have a big manufacturing background. Um, so, one of the things from a manufacturing is you always want to maximize product yield. Okay, so you have to think about that. Okay, that's a business value. I mean, obviously, the more that you can put out and be able to sell with the least amount of waste is great. So you have to think about how can you break down the yields? What are the causes of the yields? The 80-20 rule. And maybe one of them is broken and disfigured products. Okay, so you start thinking about, well, how can I go and figure out data sources that will tell me if I have broken or disfigured products? So this might be something within the last few years where you have cameras everywhere. You could take and put a camera at the end of a assembly line, and that basically takes pictures of products and make sure that you can create a deep learning model that basically can can detect if a product is broken or disfigured in some way. Is there some kind of defect on that? So let's think about that. You're going to have to go and start taking pictures of both product that are good and bad. And then have your data scientists train a model based on broken and defected. There's other quality issues that you might also want to be considering as well on there. So, you might have something where you have a lot of raw material coming in. Are you looking at the quality of that? Is that within any kind of specific specifications? Are your tools and equipment up to the best quality of maintenance that they have? Can you do some predictive maintenance around that that machine A tends to start wearing down after so many hours or so, or if there's some kind of vibrations that are happening that can detect that this machine is going to need to have a maintenance, so that you can essentially send a maintenance guy there. You might also have some regulatory type of things. I know being in food, it was really important to understand weight system and making sure that you're not giving away too much product, but you're not going under the weight requirements for those products. So, weights and so forth is, do you have a problem with your weight system that you're giving away too much product, or you're not filling up the baggage or the containers enough so that the regulatory government will be coming back to you and giving you hefty fines because you're not selling.
Or you have a customer that didn't get enough Oreo cookies in their container.
Right.
I mean, I've been to the Jelly Belly factory. I really like the disfigured products. I buy the jelly flops all the time. So keep that going, Jelly Belly factory. We like buying those because they're cheap. But I see exactly. There's so many moving parts here.
Yes.
That you've got to be worried about. I can't even imagine in manufacturing. And people, we work at Intel, we manufacture chips, not the kinds you eat though, right?
Right.
I think it'd be a lot more fun to do something in the food industry because, it's food. Everyone likes food, right?
Everybody likes food. Yeah. So, just think about the gains that you have here. I mean, if you can do something in real time of, being able to detect that all of a sudden you have a higher percentage of broken products or any kind of quality issues or regulatory issues, if you can get that in real time, you're saving the company in so many different ways than just maximizing yield. You're minimizing human tasks. So having somebody at the end of the line, I worked for a automotive company at one point in manufacturing. And, the amount of humans that they had at the end of the assembly line basically gave you an idea of how much quality there was. Obviously, human inspection is really costly. If you can replace that with an algorithm that it could be able to catch things in much more than what a human can see, and be able to reutilize these humans to do other things, like maybe fixing things that might go down, and so forth. So basically allowing humans be more humans and doing things that they're stronger on. The other thing too is you're minimizing waste. If you're using more waste, that means your yields are going down. You're spending more money on products that you don't need to, because the more that you can put out to the consumer for them to buy and be delighted with, because the other thing out of here is if they get more consistent product, you're going to be maximizing customer experience. And then the other thing too is you're also protecting the business. You're protecting the business as for, increasing revenue, minimizing operating expenses, and also any kind of other risks around regulatory issues as well. So this is a win-win-win-win scenario. So the more that organizations know how to utilize their data, being able to be able to break down their what they want to be able to gain based on a business strategy and the pains around their business, and being able to streamline that with data, the more successful companies are going to be in the future.
This has been great talking about this. And just so everyone that's listening, this is our first podcast talking about the data-centric organization. We already have 4 or 5 more planned. So pay attention. You'll see these coming out in our episodes. You can find out a lot of information on embracing digital transformation on embracing.com. Also, Sarah, you've got a great website too, where you're starting to talk specifically about data. Give yourself a plug here.
Yes. So I'm just starting up a site called Achieve More with Data. So it's achievemorewithdata.com. So feel free to go and check out any of my blogs.
Great. Hey, thanks a lot, Sarah. This has been very informative. I think it's going to be a fun series.
It will be. I look forward to it. Thank you very much for having me.
Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and embrace the digital revolution.